Hey everyone. So in this video, what we're going to do is we are going to talk about similar triangles. Now, to start talking about similar triangles, we first need to discuss ratios and proportions. So the first thing we want to know is, what is a ratio? Well, simply put, a ratio is a comparison of two or more quantities. We have three ways that are commonly used to represent a ratio. We can say from A to B, so we're comparing apples to oranges, peaches to pears, and that's just what we say out loud. The first shorthand notation for A to B is A colon B. And then we do have our mathematical expression of A over B. So it is a fraction. Now, all fractions are ratios, so they can be simplified and in fact should be simplified. Remember, they never say 900 out of 1,000 dentists recommend Crest toothpaste. They say 9 out of 10. Okay? So make sure you simplify your ratios. The most common way we are going to be writing our ratios is in the fraction form, and that is because we are using them generally to compare to other ratios, and it's easier to do in fraction form. So let's go ahead and do an example setting up ratios. A music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones in stock. We want to write each ratio in simplest form. So the first one says trumpets to violins. I'm going to open up my fraction or my function. I've got 40 over 24 because I have 40 trumpets and 24 violins. And now we need to simplify that. For the greatest common factor for 40 and 24 is 8. And if we divide both of those numbers by 8, we get 5 over 3. Now, if you use the TI Inspire or the Desmos Scientific Calculator that we use in class, you can get them to do it for you. The Inspire will do it automatically. So if you're in an Inspire and you put 40 over 24, it's going to default to giving you the reduced fraction or the simplified fraction. In Desmos, you have to do it normally and then click this button right here that says Convert to Fraction. Next one is flutes to clarinets. We have 51 flutes and 39 clarinets. And that is going to be simplified as well, of course. And they are both divisible by 3, giving us 17 over 13. Trombones to trumpets. We have 16 trombones in stock and 40 trumpets. Again, these are both divisible by 8. So our final ratio is 2 out of 5, or 2 to 5. And finally, we want our violins to the total instruments. Now, I added the instruments together. 40 plus 39 plus 24 plus 51 plus 16 is going to be 170. So we have 24 violins over 170 total instruments. And those are both divisible by 2. So our final ratio is 12 violins out of the total of 85 instruments. Next up, proportions. First thing, the definition of proportion. Well, a proportion is an equation that states that two ratios are equal. So most of the time when we say equations, you think of things with variables, but everything we just wrote in numbers 1 through 4 are equations. Equation just means there's an equal sign. Something is equal to something else. All right, so the way we write proportions, again, is just like what we were doing in numbers 1 through 4, but we're going to put them with letters. So we're going to have A to B is equal to quantity C to quantity D. Again, we are comparing two ratios and determining that they are equal. To solve for an unknown value in a proportion, we are going to use the cross product property. So what that is that A, which is the numerator of the left hand, times the D, the denominator of the right, is equal to B, the denominator of the left, times C, the numerator of the right. When you originally learned this, you may have heard it called the butterfly method because if you circle these terms or highlight these terms like that, it looks vaguely like a butterfly. But we call it cross product because we are multiplying across, diagonally across. So let's use the cross product property to solve some of these proportions. We have 4 over x is equal to 2 over 7. So first of all, we are going to go ahead and highlight the terms that we are using. And we're going to set up our proportion. So we have 4 times 7 is equal to 2 times x. Or we can say x times 2 if you want to be consistent to do the left to the right. And that'll help you keep things organized. And remember, it doesn't matter which side your x is on, it's still good. We have a property for that, remember? Our symmetric property. All right, so now I have 28 is equal to 2x. And what I'm going to do now is I'm going to divide both sides by 2. You may notice that I'm not using the formula tool for these interim steps. These are the steps that you do not necessarily have to show. And it is easier to write divides by 2 this way. All right, so we get 14 is equal to x, or you can say x equals 14. The next proportion is 19 over 10 is equal to x over 12. So again, I'm going to highlight my terms. All right, and then we're going to go ahead and set up the equation or the simplified equation. So let's do the cross multiplication. We have 19 times 12 is equal to 10 times x. And again, we get those numbers from our original proportion. So we have 19 times 12. We have 10 times x. And that is going to give me 228 is equal to 10x. We're going to divide both sides of this equation by 10. And we are going to find that 22.8 is equal to x. If you left it as two simplified fraction, it would be 114 over 5. Next problem. We have 10 over 2x minus 9 is equal to 20 over 9. And this one is, again, a little unusual because now we have a binomial in our denominator. Now we definitely want to make sure we write out this step because the next step is one that people do have a little bit of difficulty doing in their head sometimes. So we're going to make sure we do it properly. So we have 10 times 9, and that is going to be set equal to, and in this case, I'm actually going to put the 20 in front, 2x minus 9. So just for the sake of consistency, I am going to change this to 9 times 10. And the reason I'm doing that is so that we're still having the terms in the same relative position, either left or right. Right. Now I'm going to simplify this expression by both combining by simplifying the left-hand side. And then I'm also going to distribute on the right-hand side. So when we distribute, remember that means we multiply the outside term by everything on the inside. The most common error people make here is they forget to multiply by the second term. And they would put 40x minus 9, when in fact it is 40x minus 180. So now we're going to go ahead and add 180 to both sides. And that gives me 270 is equal to 40x. Divide both sides by 40. And you get that x is going to be 6.75. Or you can leave it as 27 over 4. Either answer is acceptable. Right, next problem. We have 12 over 18 is equal to 3x plus 4 over 15. So 12 times 15 is equal to 18 times 3x plus 4. Again, it doesn't matter which side you put it on. You could put switch sides. I could put the blue on the left and the red on the right. It doesn't matter. My blue statement. This is my red statement. Then 12 times 15. 12 times 15 is 180. And that is going to be equal to 54x plus 72 because 18 times 3 is 54. 18 times 4 is 72. We are then going to subtract 72 from both sides. And that is going to leave me with 108 is equal to 54x. We're going to divide both sides of this equation by 54, which will give us a final answer of 2 is equal to x, or x is equal to 2. Now, those are 4 that are required for the regular grade. Honors, you also do have to do this problem here that is notated in the filled-in version. This one is extra credit. I will go over it. These two are going to turn out to be quadratic equations because we have two x's that are diagonal from each other. So I am going to go ahead and first I'm going to highlight my terms. Then I'm going to go ahead and type them out. And I'm going to go ahead and put the blue on the left-hand side this time. So we have x minus 1 times x plus 5. And that's going to be equal to 5 times 27. Now, you may or may not remember how to do double distribution. We do have one technique that is called FOIL, first, outside, inside, last. That means I'm going to take the first term times the first term. And that's going to be x times x, which is x squared. We have, oops, I have a typo. X times 5, which is going to be 5x. Negative 1 times x, which are inside terms. So we're going to get negative 1x. And you don't have to put the 1 in front of the x. I'm just doing it for illustration. Finally, negative 1 times positive 5 is negative 5. And we are going to set that equal to 5 times 27, which, again, I don't remember what that is. 135. Now we need to combine like terms on the left-hand side. So our simplified expression is going to be x squared plus 4x minus 5. And that's going to be equal to 135. Now, if you're using the Desmos graphing calculator, you can actually stop here. But what I will do is walk through how to do the quadratic formula on this one and the next one. So when we're going to use the quadratic formula, the standard form of a quadratic equation is going to be ax squared plus bx plus c. And we set that equal to 0 in order to solve for x, because remember the solutions to a quadratic equation is where does the graph cross the x-axis? Where does y equal 0? Right, so we want y to be 0. It should technically be y here. The easiest way, or the quickest way, and always effective way to solve a quadratic function is to use the quadratic formula, which is going to be x is equal to, and I'm going to go ahead and make my fraction bar, opposite of b, or negative b, plus or minus, that is a special symbol, the square root of b squared minus 4ac divided by 2a. So we're going to use the a, b, and c from the equation. First, we need to set this equal to 0, and we're going to do that by subtracting 135 from both sides. You don't actually have to show that particular step. We do get x squared plus 4x minus 140 will be equal to 0. Okay, so now we have our a, b, and our c based on this equation here. So if we do this, we will see that a is equal to 1, b is equal to 4, and c is equal to 140, or negative 140, sorry. We substitute that information into our equation, or our formula, so we're going to get x is equal to negative, and our opposite of b is 4, so minus 4, plus or minus the square root of b squared. So that's going to be 4 squared minus 4 times a, which is 1, times c, which is negative 140. Make sure you don't forget that negative, because otherwise it won't work. And it's going to be divided by 2a. The reason we have plus or minus the square root is that every square root actually has two answers. Because if we think about it, 5 times 5 is 25. Negative 5 times negative 5 is also 25. So the square root of 25 is positive and negative 25. So what I'm going to do here is to save time. I'm going to run this entire expression, the square root of 4 squared minus 4 times 1 times negative 40. I'm going to run that through the calculator, and I'm going to get 24. So I'm going to break down the next part of this equation into two parts. So I'm going to break down the plus or minus. So we're going to have x is equal to negative 4, and I'm going to start with minus because I want the lower number first, 24 over 2. And the other answer is going to be negative 4 plus 24 over 2. Now, negative 4 minus 24 is negative 28 divided by 2 is negative 14. And negative 4 plus 24 is 20. And that is divided by 2, so that's going to give us negative 14 and 10. Now that will work on every quadratic function. If it is going to cross the x-axis, if it's solvable, then you can also run it through the Desmos calculator and check your work. So you can actually do it from this step, the very first step. Put that into your Desmos calculator, hit enter. Now you might be wondering where it is. Well, it's out here. We have to zoom out. Then we can click on the graph and we get that this is 10, 0. So x equals 10. And this is negative 14, 0. X equals negative 14. You can't do it that way in the Inspire sometimes, so it's easier if you do it from, in the Inspire, it's usually better if you go from this part and put y equals this, the x squared plus 4x minus 40. All right, on the final one, we have 2x plus 5 over 6 is equal to 7 over x minus 6. So first I'm going to highlight my terms, doing the cross product property, simply because it tells me to. And then I am going to do the multiplication. So we have 2x plus 5 times x minus 6 is equal to 6 times 7. And then we're going to do our double distribution. So 2 times x is 2x squared. And so I'm going to actually go ahead and draw the arrows on this one. So we have 2 times x. Next, we're going to do 2x times x. Next, we're going to do 2x times negative 6. Then we will do 5 times x. And last, we will do the last terms. So 5 times negative 6. So we have 2x times negative 6 is negative 12x. 5 times x is positive 5x. And 5 times negative 6 is negative 30. 6 times 7 is 42. Now we're going to simplify the left-hand side by combining like terms, which gives us 2x squared minus 7x minus 30. And remember, you can only combine numbers or terms that have the same variable and exponents. And that is why we can't combine negative or 2x squared and negative 7x, because this is x squared, this one is x. It's like we can't actually, if I told you to sort apples and oranges, you would put apples in one basket and oranges in the other. Now again, at this point we can graph it, which would be the easiest solution. So for this one, that is what I'm going to do. To show the answer first, we get 8 and negative 4.5, or negative 9 over 2. Let's do this though, the more quadratic formula. So we have 2x squared minus 7x. And we're going to subtract 42 from both sides, which gives us negative 72. That's going to equal 0. A equals 2. B equals negative 7. and c is going to be equal to negative 72. Then we'll run that through the quadratic formula. So x is equal to negative b, which is negative 7, plus or minus the square root of b squared, which again is negative 7. Make sure you put this in parentheses because there's a negative. Minus 4ac, and a is 2, c is negative 72, and it's going to be divided by 2 times a. All right, we're going to simplify that out, so let's go ahead and put this part into Desmos just to make life easier, because it's going to be 49 inside these. Square root is going to be 49, and then negative 8 times negative 72. I don't actually know what that is off the top of my head. So for speed, we're going to say that all of that together is 25. And most calculators will allow you to type that whole expression in, so it's not special to this calculator. I don't know about Apple calculators, though. All right, we're going to break it apart again. So we're going to have negative 7, which is going to be positive 7. We're going to subtract 25 and divide that by 4. And then we're going to take 7 and add 25 and divide by 4, which is going to give me that x is equal to negative 9 over 2, or negative 4.5. And what did I get there? 36. All right. And again, this actually should have the curly brackets around the solution set, but I won't take off points for that at this time. Okay. So that's the two that are quadratics. Don't fret, we're not going to use it too much immediately, but we will be using it soon. All right. Next set of problems, we're going to talk about similar polygons and specifically similar triangles, but similar triangles are the same as all similar polygons. Okay. So similar polygons. Polygons that are the same shape but different sizes. How can you tell if two polygons are similar? Well, two polygons are similar if the corresponding angles are congruent, and both of these things must be true. Their corresponding sides are proportional. All right. The ratio of the corresponding sides, we call that the scale factor. And if polygons are similar, then their perimeters are also proportional. So again, that just makes sense because the sides are proportional and perimeters all the way around. Now, similar to our congruency statements, the order of the letters, which are our vertices, is important. Corresponding angles will be in the same relative location, and the symbol we use for similar is just the squiggle. So in this example, in the image below, triangle ABC is similar to triangle DEF. So A comes first, D comes first. So we have A, we have D. You notice in our picture, A and D are the same measure. B and E, and they are still two arc marks. And finally, C and F. And this is why you can't use angle, angle, angle to do congruency statements. All right. So since we are told they are similar, we don't need to write too many of the proportion statements. What is important is which one goes on top and which one goes on bottom of the proportion. Remember, the first one is always the top, and the second one is always the bottom. The numerator and denominator. Right? So let's first look at triangle ABC to triangle DEF. We're going to just pick, I'm going to use AB and DE for all of these. So we have 8 over 12. And we're going to set that equal to, oh, that's just the ratio, sorry. Yeah, simplify it. Both of these are divisible by 4, so it's 2 over 3. And we can get the same thing. If we run 10 over 15, they're both divisible by 5, 2 over 3, 2 over 3. It's going to be the same each time. And for the reverse, all we have to do is flip it. So now it's 3 over 2. I don't have to do the math again because we already did the math. Now, what we can do, though, is it wants the perimeter of triangle ABC to perimeter of triangle DEF. So 8 plus 10 is 18, plus 24 is 32. Okay, it is 32. So the perimeter of triangle ABC is 32. And the perimeter of triangle DEF, which is 12 plus 15 plus 21, is 48. And we're going to simplify that. I can tell you this is already 2/3. And look at it again. There it is. It's 2/3. So the scale factor, or the scale factor of perimeter will be the same as the scale factor for the sides. So first of all, let's go ahead and list all our congruent angles here. And we're going to mark them as well, write a proportion that relates to the corresponding sides. So I'm going to use my drawing tool. It says JKL is similar to PMN. So J and P, K and M and L. So we're going to say that the measure of angle J is equal to the measure of angle P. We can also say that J is congruent to P, so angle K is congruent to angle M. And angles are always with the capital letters here. And then we can say that L and N are congruent. So angle L is congruent to angle N. And then for our sides, we're going to compare the sides that are together. So between the 1 and 2, JK, and 1 and 2, PM. So same concept as we did with the similarities, or the congruencies. So JK to PM is equal to KL to MN. And then we have JL or LJ. I'm going to say LJ over NP. So now it's telling me that triangle XYZ is similar to triangle RYS. So again, let's mark the congruent angles. So X and R, Y, and Y. Y is congruent to itself. S, one triangle is in here together like this. One triangle's in the other triangle. It's a little easier to find the corresponding sides. So our congruent angles, our angle X is congruent to angle R. Angle Y is congruent to itself. That's our reflexive property. Never forget. So angle Y is congruent to angle Y because things are always congruent to themselves. And then angle Z is congruent to angle S. And oops, I'm not in the right spot. Same for the sides. So XZ is corresponding to RS. XR, not XR, XY, that's the whole length of the side, and RY, and YS, okay, I'm putting the big one on top, sorry, ZY over SY, or YZ over YS. Right, we're going to determine the scale factor, and then we can find the value of X. So if these are similar with a scale factor of 6 to 5, find the value of X. Well, we're just going to do a proportion, just like we've been doing. So we're going to say 6 over 5 is going to be equal to, so big one to small one. We can see that this is the big one to small one, left to right. So we're going to say X over 28. And then we're going to cross multiply, get 5x times 28. Okay, so when we do that cross multiplication, we're going to go ahead and get 6 times 28 is equal to 5 times x. And 6 times 28 is going to be 168. Is going to be equal to 5x. So we know we're going to get a decimal because 168 is not divisible by 5. But we're going to go ahead and divide both sides by 5. And that's going to give us 33.6 or 168 over 5. So we can leave it, or I'm going to go ahead and put in a decimal. So let's put 33.6. So 33 and 6/10 is equal to x. All right, so if triangle ABC is similar to triangle DEF, find the value that's missing. So let's go ahead and we're going to say AB and DE. Let's go ahead and set up a equation. And DE. So we want AB to DE is going to be equal to BC to EF. Again, it's the same way as we did with the congruent statement. So AB are the first two letters, DE are the second two letters, or the first two letters as well. And then BC is second two letters, EF is second two letters. So AB is our unknown value, and that's over 28. So x to 28, DE is 25. X to 25 is going to be equal to 28 over 20. Then we cross multiply. So we get 25x times 20 and 25 times 20. It's not divided by, times 700. So that's going to give us 20x is going to be equal to 700. Divide both sides by 20. And we're going to get that x is equal to 35. Next one. AGM is similar to KXD. So that's going to be AG and KX. So let's set up the equation. AG over KX will be equal to GM over XD. Now you might be worried because we have too many x's, but we'll notice that x's are going to both be on the bottom because they're in the same triangle. So that's actually going to make it easier for us because it will have the x's on both sides of the equation instead of multiplied by each other. So AG is going to be 32 and KX is x plus 3, and that's going to be equal to 36 over x plus 6. And we're going to go ahead and cross multiply just like we have been. And then that means we are going to have 32 times x plus 6 will be equal to 36 times x plus 3. And again, it doesn't matter what order you put your terms. So I am putting the coefficient or the whole number, the constant, in the front because that is technically more correct and looks nicer. 32 times 6 is going to be 192. So the left-hand side is 32x plus 192. And then we need 36 times 3, 108. So we have 36x plus 108. So what I'm going to do is I'm going to go ahead and subtract 108 from both sides. And that's going to leave me with 32x plus 84, I think. Let's check. 84. And we'll set that equal to 36x. We need to subtract the 32x now from both sides, or 32x from both sides, sorry. My brain went a little haywire there for a moment. Which will leave us with 84 is going to be equal to 4x, because 36 minus 32 is 4. And finally, last step, we're going to divide both sides by 4. And that is going to give me 21. So x is going to be equal to 21. Finally, last question for this tab. We have triangle ABC is similar to triangle ADE. All right, so let's set it up. We have AB, and we're given AD We are given BC, or something for BC, and we are given something for DE. Again, just make sure you have the same triangle on the top and the same triangle on the bottom in this case. So AB is 28, and I got that by adding 20 plus 8. And then, of course, AD is 20. Then we have BC, which is 2x plus 3 over 15, which is DE. Again, what we're going to do is cross multiply. So 28 times 15 and 20 times 2x plus 3. So we're going to have 28 times 15. Oops, not over. Times 15. Sorry guys, I had a typo there. Is equal to 20 times 2x plus 3. 28 times 15 is going to be 420. And we're going to set that equal to 40x plus 60. Again, because I'm multiplying 20 times 2x and 20 times 3. My next step is to subtract 60 from both sides. And 420 minus 60 is going to be 360. And that's going to be equal to 40x. Divide both sides by 40. And we should get that x is equal to 9. Okay, so we get 9 is equal to x. And that's the last problem on this page. Remember, once you finish this tab, turn it in on Google Classroom by clicking Mark as Done. Do not turn in the final document until I tell you to do so. Again, that's all I have for you tonight. Thanks for watching. I'll see you later. Stay safe.